Hello, Eric. Hello, Ryan.
Hello, Mr. Teacher. Hello, Mr. Eric.
Okay, sit down, please. So today, do you still remember the linked list? Yeah, the linked list. Wait, the linked list. Okay,
Not me.
the linked list.
Linked.
So we have a different notes, yes?
We're always talking about the linked list.
Because there's so much fun talking about this. Okay, so the linked list. Now 1, 2, 3, 4.
5, 6,
No, that's it.
7,
4 notes.
8.
Keep quiet, please. Listen up. Now, this is given this head, yeah?
Head. We keep saying head
Head.
every time.
Okay, so if I tell you that all the numbers in a linked list are unique, you know, so they're not duplicate numbers, they're just unique, yeah? Unique.
Means different.
Different. They are numbers are different. So
They're all different.
so now I give you a number, yeah? I give you a number like a 2. Can you remove this from the linked list? Yeah? Okay, remove this. So I give you a
Why not?
value, yeah? All I want you to do is remove the value from the linked list. But pay attention, it's unique. All the numbers are unique. So if the value does not appear in this, then that's fine. Just return, just modify. Just don't modify the linked list. But if there's a value, like if the value is 2, then all I want you to do is take this out, yeah? Take this out, and then link this here, okay?
1, 3, 4.
Yes, so just to take it out. Any ideas? Any ideas?
Just take the second one out.
Yeah, I know,
Just
but
take
if,
it out. Then
yeah, how do you take it out?
just cross it. You just cross it.
Well, that's all.
You just rub it out.
Yeah, but how do you ask computer to rub it out?
We said rub it out, computer.
So how many cases are there?
1, 2,
Yeah.
3, 4, 2.
2 cases. Why is that? If the value is the head, yeah?
Yeah.
Then we just need to return that it's head the next, right? Yeah? If it's not a head, then we record the previous note. Yeah? And then another note. So this is current. So what do we do now? Previous dot next
Equal
equal
current.
current dot next.
Yeah.
Because it is now equal to current, but we need to make it equals to current dot next. Yes?
Yes.
Okay.
Yes.
Okay, so let's do this, okay? Define, remove the node, okay? And then we give it a head and a value, okay? What's missing?
Always.
Okay, so now if you are given a head that is none, yeah,
Oh.
then we just return, okay?
Return.
Return none, okay? Because you are given nothing, then there's no point to look for it, okay? Am I right?
Yeah.
Okay, so now, if head dot value is value, okay? So what happened here? What happened? If the head of value is the value, Eric,
Yeah. Return.
return what? Return what? Return what?
While you're reading that Chinese book.
Look, Eric,
Yeah.
this is 1 and we are removing the 1. This is head. So what should we do? Return head on next, right?
Yeah.
We just abandon this. We don't want it. Yeah? Am I right? Okay? So now if we so what should we do now? We can do this in recursive way. Look, we can say head dot, because head, if at this point, right? If at this point head is not the value, right? It's not the value we are looking for. we should keep it.
Head dot
Next equals
current dot next.
no.
Why?
Remove. We can do this recursively. Remove node.
Bracket.
Head dot next. Right? Okay. So recursively, you think about this.
You need a closing bracket.
Yeah. Look. Now I'm here head. Yeah. Head 1. So now this is not the value we're looking for, but the head dot next is some another linked list. So we need to keep this node, and its next equals. Okay, it must be somewhere here. Remove next node. Okay, and then I just need to return what?
Return. Remove.
Return what?
No. Current.
There's no current. Come on, don't make the game.
N. 2. N.
Where's the node? Where's the n now? Where?
False. No. Define.
Return what? The
Head.
of course head, because head I keep it, yeah? Yeah? Am I right?
Yes.
Okay, so this is one way. And how about we do it in non-recursive
I
way?
should have got that.
Yeah, you see, do you understand? Head to next equals, because now at this point, the node to remove must not be the head. It must be possibly, but it must be in somewhere head to next, right? And I use the remove node to recursively check. Yeah? Alright? Alright? Am I right?
Yeah, you're right. Yeah.
Yes, you are.
Papa.
Return head, okay? Now we can do this. Define, okay, if this is I copy here, I copy here, and I copy here. Okay, so y. So now I have p equals head. P equals head. Then head equals head dot next. Alright? Because currently the head is not the node we are looking for. Then we say this y. We possibly need to save the. This is previous. Okay, let's do it previous. Previous node, and then current node. But we need to. Let's say we have current node. Okay, current node equals head dot next. Previous node equals head.
See?
Okay, and then y current. One current node is not known. Right, look. If current node dot value is equals to the value we are looking for, right? Now we found the value we need to looking for. Now what we do? Previous dot next equals what?
Previous dot next equals current dot next.
And then we just need to, because I just told you that it only had all the numbers in the linked list are different. So at this point we can return, right? Return head, right?
Yeah.
If not, if this is not, this is not found, then previous current will be equals current, and then the current will become current dot next, right? Yeah. So the previous node will become current node, and the current node will become current dot next node, right?
Yeah.
Yes. So this is another way of doing that. Look, we just have remove one. Okay, so we only remove one node. Okay, got it? Yes. But this one, is it removing only one node?
No.
If look, this one is only removing one node, but this one may remove more than that, right? Because look, if head is value is if they are duplicate numbers, then you will return head on next, right? You return head on next. Head on next equals remove node head on next. So these two are not exactly the same. You will remove if they are duplicate numbers, and then the number you're looking for is the number you want to remove, right? Then
what?
if head dot value equals value, then I return head dot next.
Yeah.
Then if there are two values, you remove head dot next. Yeah, yeah, I think this will work. This will work. Yes, my mistake. If you want to remove everything, if you want to remove every numbers, there are multiple numbers, yes. If there are multiple twos, you want to remove. So if there are multiple nodes, you want to all remove it. So add here, remove. Before this, return remove node head or next. Like in this case, you will remove every node. Okay, and this one. If you want to remove everything, so I'm not returning head here. So if current value equals value, previous dot next equals current dot next, and what should we do? Previous equal
1 plus
and
2
then
plus
and then
3.
look. Okay, so this is previous, this is current. Okay, so now I just link it. Okay, so now I need to move this. Previous equals current, and then current equal and then I need to put here current equals current dot next. Right? So because this is the node, right? This is the node I'm going to remove.
Yeah.
But when I relink it, I need to move the current into the next node, right?
Yeah.
Into the next node. And then after this, the previous current, and then we just need to shift one more time. Right? Yes?
Yes.
And how about this is the same? Look, if this is 2, this is 2. So that will become a problem, right? Will that be a problem? Because you're here, and then you move it to here, and then you move it to here, but this is not removed. Okay? This is not removed. So in this case, we have to, it'll be tricky here to write here. So you have to change this if to y. Y current now equals the value. Right? And I need to do this. Previous dot next equals current dot next. Current equals current dot next. Right?
Yes.
Yeah, and after this I can relink it. Another way of doing it is what?
Yay.
Yeah?
I don't know.
Okay, so I think that's enough for today. Let's do the coding.
Yeah, let's do coding.
Yeah, do the coding time. So,
Oh.
don't look at it. Come on. Close turn off the lights, please. Turn off the lights. Can I?
I can't see anything.
Can you not jump every time I told you? You're on YouTube, and when you keep jumping and then the people are not seeing it, the screen will be shaking.
Pie.
Okay?
Why we
So-
need to always show that?
Yeah, remember we have lists there, 1 to 9, yeah? We have the print list yesterday. So we kind of need it, print the link list. We don't need this. So
Hey, right.
so let's print the link list. We need this then, but we don't need anything after, right? Yeah? Okay, so now if I print the linked list, so what does it
What does it mean?
so what does it print? It print the 1 to 9, right? Let's remove the number 5, okay?
What number 5?
Number 5 in the node, in the middle. Let's remove the middle node, okay? Yes?
Remove.
Let's add a parameter here. So let's say before, okay? Then we can add a message here, and then let's say print message, okay? So now we can do this. Now let's remove it. So define remove the node head value. Let's try the first one recursive, okay? Let's try the recursive one. So if head is none, return what? None, right? If head dot value is the value we're looking for, return what? Head dot next, right?
Yeah.
Yes? Otherwise, what? Head dot next. Actually, this is the.
Let's go next equals remove.
next node. Next node equals remove node, right? Head dot next node value, right?
Yeah.
Yeah, and then let's try if it is work. Okay, remove node head.
Not a little bit.
5. Okay, and then we need to, because we're not sure if it's the head is removed, we do this. Head equals remove node head. Okay, and then print linked list head after, right? Does it work? I'm not sure, okay?
You're not sure?
Yes? Oh, no, it doesn't work. It doesn't work. Look, after it has nothing. So what's the problem?
After have nothing.
Remove the node head of value. Why it doesn't work?
I don't know.
Head of equals head of if head of value is the value we are looking for, then we return head of next node. It seems alright, right? Does it seem alright? Why is it not working? Can you guess?
Because neither after the after head will move node head 5.
Why it doesn't print anything? Print head. You see? Because you're not returning anything, right? You need to return head, right? You're not returning anything, so it doesn't print anything. Yes? Look, the 5 is gone, right? You see? Yeah? It's a bit tilted, right? A bit tilted.
Never mind. Let's see.
No, but I
Is
think
it
yeah, I think that's okay. That's okay.
never mind.
Okay, so let's look. How about if we have multiple values? Let's see. Does this version remove 2 5s? Okay. Yes. So let's see. Let's add. Let's add another node, which is 5. Okay. Does it remove all of it? No, it doesn't remove it. Look, before it will be 5 at the beginning, 5 at the end. It does not remove it, yeah? Right? The second node is not removed, right? So, easy fix would be just do this. Remove node head the next node, right? Uh-oh. Ah, yeah.
Red.
Sorry?
Should be in red if it's there.
Because the remove node head or next the value, because we're missing the parameters here, right? We need to specify what you want to remove. Yeah, you see? So get it. Do you get it?
I get it.
There are two, 1 5, the other 5, right? And we remove when it's removed, we remove this one, so it's gone. It's gone.
It's like the monster likes to eat 5s.
Yeah, monster is 5. Okay, so this is the recursive version, so it's working. How about we do this non-recursive version, which is, let's call it remove number 2, okay, version 2, okay? Define remove node 2, head value. If head, this is the same.
Where's the flyer?
Return none, right? Yes?
Yeah.
So now, if head is none, return none. If head, so let's say previous node equals none.
I know what conjunction.
Current node equals head, right?
Conjunction.
Why current node is none. So we also have to check if if head of value is value. If head of value is value,
Head dot value is value.
then I can do this recursively. Remove node 2 head the next next node value, right? So this is the way I can make sure the first node is not the node we want to remove. Okay, current node equals head on next node. Why current node? Return head, right? One current node. So why current and current is not none, right? None. And current dot value is the value we are removing. We need to link previous dot next node will become the current dot next node. Then previous current will become current dot next node. Yes? Right? Previous next node, previous next node, and yes. Then if current is none, then previous was current. Current will be current. Like current will be none, right? So now if current is none, then I just need to break. Right? Let's try. There's a problem. Which is not right. It's a bit tricky. Let's double check. Why current? Yeah, we forgot the current equals current on next, right? Here, current equals current on next node. Okay, got it? So let's try remove the first one, okay? Let's try remove the first node. We just want to remove the first node, so you should print the 2. 2 to 5, yeah? The first node is 1, yeah?
I guess.
What happened?
It just shakes. I'm doing it over here.
No, it's not working. Look, there's something wrong. What?
The heck? What?
No, I didn't save it. Did I save it?
Document. Did you?
Did I save it?
Oh my god, a document. Oh yeah, that.
Yeah, it's working. Look, it's working. Look, yeah? The one is gone. This is the one version. Let's try the other version. Let's try the other version. Yeah? Does it work? Yeah, it also works, okay? It also works. So today, to sum up, we have 2 versions, yeah? 2 versions of remove the link node. And both versions are able to remove the node with the value multiple times. Don't, please. Yeah, let's try.
What?
So this is the, yeah? So here, because the special condition is that to deal with the first node. If the first node is the node we're going to remove, we have to pay special attention to it, right? Alright, do you get it? This one is a bit easy to understand, right? Because if you think about it recursively, then this one is easy. Let's just talk about the first one. Which one? This one. Look, it's easy to understand, right? From line 24 to line 30. Okay, let's do that. Look, please. Look, if head is none, return none. Yeah. If head value is the value, then this value will be removed. This node will be removed. Now we just remove node. Remove the next bit. We are abandoning the current node, right? Abandoning the current node, the head, right? Because we know the head is the node we are going to remove. Now we abandon it. We remove the node, the head on next node. Otherwise, this node we are going to keep. The head on next node equals remove node. Okay? So do you get it? Yeah? Do you get it? So which one you think is easier? Is faster?
All of it.
It's easy to understand.
All of it.
All of it? All of it? Eric, what's your opinion?
I don't know.
You don't know?
I don't know.
Okay. Okay. Thank you. Good job today. Say bye bye.
Bye bye. Bye bye. Bye bye. Bye bye. Bye bye.
Good
Bye
job.
bye. Bye bye. Bye bye. Bye bye. Bye bye.
Okay. Okay. That's it. Can you turn on the light, please? Turn on the light, please. Ooh. Look at this.
Oh, look at that.